all about adding.
Thank you. That's great, thanks very much. Building on what Mrs. Burnett's just said, before we really start getting into any addition, we'll start looking at one more and one less, so that the children understand where one more and one less will be on a number line or on 100 square. If you think about 100 square actually just being a 100 number line chopped up, it makes it visually just a little bit easier. But we do a lot of work on what's one more than 5, what's one less than 5, what's one more than 6, what's one less, so that they're really very familiar with the order of those numbers. Having done that, we then move on to what is 10 more and what is 10 less. So it's building on that place value so that the children understand that if we've got 28 and we have 10 more, what's changing? What's changing is the 10, but we're not changing the units or the ones, they're actually staying the same. So we'll do lots of work on that more and less. Then we'll get on to some addition as well. But we start off by doing addition practically. So we just have our dinosaurs out, our compare bears, our counters, whatever it is, and we would do addition as combining groups. So literally, I had 3 lollipops, Mrs. Burnett had a lollipop, how many have we got all together? Let's actually count them. So we're not writing anything down at the moment, we're just understanding that what addition means, or what adding means, is just combining 2 groups of things together, and lots of different ways in which you can do that. When we're happy that the children practically understand that, we might move on to a lollipop line. And the lollipop line is simply a number line, and it's got these lollies on the top. But the beauty of it is that you can pop counters on the top, and you're not covering up any of the numbers on the line. So we can say to the children, okay, well, you've got 3 counters, and you've got 1 more counter, let's put them on our lollipop number line, and they can actually visually see, well, it's 1, 2, 3, we know we've got 3 there, we've got that 1 more, oh, and we can see the numbers underneath on the number line. So that would be our next step. Having done that, we'd then take away those lollipops, because we're now happy that the children are able to actually visually see the numbers. And if we've got, for example, this is 3, add 2, we'd say, okay, how can we do that on a number line? What number are we starting with? We're starting with a 3, so the children would find that number first, and they would do a jump for every one that they're adding on. That's taking us to 5. I think you can start to understand why the children have to understand what combining those things means before we ever get to any of these number lines. And then finally, what we might say to the children is, okay, well, we don't actually need the number line with the numbers on, we can now draw our own number line. So if, for example, we wanted to do 5 and 3, we were saying to the children, we want to know what combining 5 and 3 would be, let's draw our own number line. Now some children might find that a little bit difficult, just having a blank line, so we might say, okay, well, let's pop a 0 on there just to help us. And we might want to put on our own numbers, 1, 2, 3, 4 and 5. And we'll mark on there 5. How many jumps have we got to do? We've got to do 1, 2 and 3, and the children can put on their own numbers there. So they don't actually have to have something that has the numbers on, they can do it themselves. And that, although it seems quite sort of laborious to do, that's actually a brilliant step for where they will go further. Coming back to partitioning, what Mrs. Burnett said about partitioning, it's really important that the children understand partitioning, because as they get to adding 2-digit numbers, we will partition those numbers, we will split those numbers into their tens, into their units, and because the children are very familiar with how to do that, they can then take those numbers apart and recombine them. So taking them apart means taking our 45, which is 40 and 5, taking our 30, which is 30 and 3. So we're still saying that what's on this side is the equivalent of this side. So we talk a lot about equivalence as well, so that the children really understand that that means the same as. Having done that, we would then combine our tens, giving us 70, combine our units, giving us the 8, there we go, and then we'd finally put them together, so thus giving us our total of 78. If they haven't understood that early partitioning though, that would be very difficult to do, so that's why the partitioning step is so important. Right, that's not going to fit on there, so what I've... yes, I'm not sure it's going to fit with this visualiser though. Hold on.
There's one round.
There's one right at the top
On
of
the
the room.
room,
Yeah.
Top of the room.
Yeah, I wanted to, yeah, I could do it, couldn't I? Yeah.
I'll hold this way.
Thank you. My lovely assistant here. This is a 100 number line. It's actually double-sided. So on one side it's blank, on the other side it's hundreds. So what we can do with a 100 number line is, if we just go back to this calculation here, if we wanted to do this on our 100 number line, we could mark our 45 on our number line. So the children have whiteboard pens, so just a black pen, so they'd find 45 on their number line and mark it. This is one way they could do it. They could then, if they're comfortable with 10 more, do jumps of 10. So they'd go 45, 55, 65, 75. That's if they're comfortable with 10 more. And then they could do the 3 units, thus bringing them to 78. If they're not comfortable with that, or they prefer a different way, because children all prefer different methods, what they might choose to do is actually to partition the numbers and say, well, first of all, I actually want to do the tens. So they might mark 40 and do 50, 60, 70. Some children just find that a lot easier. And then add on or count on the 5 and then the 3. Neither way is right, neither way is wrong. Children have to work out what works best for them. I'll have to jump over that. So that's what I've just done. Going to the blank number line. Again, when the children get to the stage where they no longer need the numbers on, they can have a blank number line. They might want to start at the 45 there and then count on the tens. Now, when the children get to that stage, they don't actually have to write everything down. But what they will be doing is 45, adding 30, and then 3. One way they might do that is by jumps of 10. That's a 10 jump, that's a 10 jump, and that's a 10 jump. So each of those jumps is 10. And they'd mark underneath what those jumps were. That's the 55, the 65, the 75. Some children will be able to miss that out. And then they would do the single jumps, the 1, the 2, the 3. 76, 77, 78. Right. Finally, not quite finally, sorry, I nearly said finally. The children would then, when they're comfortable, when they're ready to, they will then go through the same process with the hundreds. So we'd partition the numbers down into the hundreds, the tens, and the units. Combine the hundreds, combine the tens, combine the units, and then put them all together. So you can see how that partitioning is just so important for their understanding. And again, with a blank number line, the children would mark on their blank number line for... It's gone out. That's gone out sync now.
Because you're close to the edge.
Yeah, could be, couldn't it? Yeah, you're right. Thank you. They're starting with 427. If they're thinking about partitioning, they're going to be doing 427, add 300, add 20, add 1, possibly. It's one way they could do it. And they would do jumps of hundreds. I don't know how many it was. So each of those would be, sorry, told you it was easier doing an assembly this morning to 240 children. They would be adding hundreds each time. 527, 627, 727. Then they would do the tens, 2 of those. And then the unit to get to their total underneath. But not all children will be ready to start with that 427. So they may need to partition the whole thing and do 400 to start with, and then add on the hundreds, and then add on the tens. Children can be comfortable with either way. And then finally, when the children are ready, they will do what we call vertical calculation. So they will write their calculations down in a vertical way. We don't refer to them as hundreds, tens and units columns, but we do call it vertical. And the way they will calculate this is to first of all total together the numbers in the ones or the units, those ones or units, which is 11. And we don't say that we're carrying anything over. We simply say that 8 plus 3 is 11. And we would write 11, making sure that the 1 is below the units and the 10 is below the tens. That's important. They then calculate the total of the tens and write them underneath, making sure that the tens are in the same, try not to say column here, underneath the tens. We have a 0 here because we have no units, and we term 0 as a placeholder. So it has to be there because it's showing us that there's not actually any value in there. And we got 100, so that's underneath. Then finally, we'd calculate how many hundreds, and we'd put the hundreds there, 7, placeholder for the tens and for the zeros. And when we've done that, we can combine all of those by just adding how many hundreds together, how many tens, and how many units all together. That would be the final stage, really, that we would get to. I think that's me on addition. Oh no, vocabulary, sorry. Sorry, I nearly got you there. We spend a lot of time talking about the different words that we can use that mean the same thing. So we've got add, addition, plus, how many more to make, how many in total, equals. The children need to be comfortable with all of those terms. How many more? Because if they understand all of those, they've got a really good chance of being able to carry out any sort of calculation or problem that we want them to do. Thank you, Mrs. Burnett.